Question 2 from the graphing calculator section says a particle moves along the x-axis with velocity given by v of t equals 10 sine of 0.4 t squared, all divided by t squared minus t plus 3. So it's important to note that this is a rate function. The velocity is the rate function of the position. And this is for t between 0 and 3.5. And we are also given an initial position of x is negative 5 at t equals 3. So question A asks, find the acceleration of the particle at t equals 3. Well, the first thing we need to make sure we recognize is that the acceleration is the derivative of velocity. And we want to use the slope function on the graphing calculator. So we want to graph this function v of t, and we want to use in the calculator menu, we want to use this one here. Okay, we want to use dy by dx, and we want to calculate the dy by dx at t equals 3. So going to our calc menu, once we've graphed this function, we want to find dy by dx, and we want to do, it will give you the option at x equals, and we want to use x equals 3. So a of t, a of 3 is equal to v prime at 3, and from the calculator, we're going to get negative 2.11819. Okay, so our acceleration is going to be negative 2.11819, and that I think is in meters per second. Okay, the alternative would be to use the quotient rule. Now, I'll do this in a different color. Now, we probably don't want to use a quotient rule, but we could. So we could actually calculate a of t as the derivative, and we're going to end up with, we have to use a quotient rule here, so it's going to be 10 cosine of 0.4 t squared. We have to multiply that by the inside derivative, so 0.8 t, and then again multiply that by the denominator, t squared minus t plus 3 minus sine of 0.4 t squared, and then the derivative is going to be 2t minus 1, and all over the derivative of, or the square of the denominator. Okay, so which is, we can then use this acceleration function and calculate the acceleration in that way. Okay, and I think I made a mistake here. This should be meters per second squared since it is acceleration. Part B says, find the position of the particle at t equals 3. Well, the position of particle at t equals 3, we start with at t equals 0, the position is negative 5. That's our initial position. So our position function x as a function of t is going to be equal to, we're starting at negative 5, and then we're going to calculate the area or the displacement from 0 to t. Okay, and that's going to be under the velocity function, which we'll call v of x. So to find the position at t equals 3, we're going to just plug in our bounds, 0 to 3, and the area underneath that function, we're going to use number 7, the integral of f of x. So here I've graphed that function, and the area that we've calculated from 0 to 3, a part of it is going to be negative, but the net displacement is 3.2397. Okay, we'll round that to 9/8. So it's going to be, the position is going to be given by negative 5 plus 3.2397, okay, given the displacement. So the new position is going to be, just use a calculator just to make sure that we're getting this right. So -5 plus 3.2397, and we get -1.7603, and that's going to be in meters. Okay, so if we take a look at the mark scheme, for A, we just need to calculate that acceleration. You can do it any way you want. We use a calculator to do this. For part B, there's 3 marks. 1 mark is recognizing that the area from 0 to 3, that's our displacement, and using the initial condition, the starting position, and the answer of -1.760. Okay, that will give us the full 3 marks.